just because the names are really long. It's the properties of like exponents.
Well, let me turn my volume up just a little bit. I'm having just a little bit of difficulty hearing you. Okay, that should be.
It's the properties of exponents.
Oh, okay. You have some problems that you can verbalize?
Oh yeah. Yeah. In parentheses, -5z, and then in unparentheses, to the power cubed.
Like that?
Yeah.
Okay.
And then it would go like -5 3 times z 3 to the power cubed.
Yeah. In other words, this 3 is an exponent for everything inside the parentheses.
Uh-huh.
That is not the same as this. Very different. In the one below, the 3 only affects the z.
Uh-huh.
But because of the parentheses, we have to cube everything.
Uh-huh.
So you're right. It's kind of weird. My eraser stopped working. Now my tablet doesn't want to work. Okay, so I can separate everything out and do the number separately. And then do the variable. In other words, that's the same thing.
Uh-huh.
What's minus 5 cubed?
-125. I have like a cheat sheet in front of me because that's what she gave us.
Okay. Actually, I'm glad they give you an answer sheet, but you'd be better served if you put it away while we're working.
Uh-huh.
In other words, it's too easy for you to look at the answer sheet and read off the answer. I don't want you to do it that way. I want you to work it through in your head. In other words, I want you to be a little more active in coming up with the answer. It's when you do that that you learn.
Mm-hmm. Okay, I'll put it up.
All right. So what else do we have?
4x in parentheses and on parentheses to the power of -4.
All right. Let's talk for a moment about what a negative exponent means. If I said 3 to the -4 power, first of all, negative exponents do not mean negative numbers. In fact, they are almost always positive. Is all it means is the reciprocal. In other words, if I put 1, that's the same thing.
Uh-huh.
So if we apply that to the problem, you get, instead of 4 to the -4 power, I'm going to say 1 over 4 to the +4 power. And it's x to the -4. And I can either write that one of two ways. I can either do this. However, frequently they will want you to give your answer with all positive exponents. And so instead of putting it in the numerator, I'm going to put it in the denominator like that.
Uh-huh.
And then 4 to the 4th, I believe, is 256. So 1 over 256 x to the 4th. Now, the other thing about negative exponents, let's say I had this. I had 1 over 3 to the -2. I can always just move that number to the other side of the divider line and make it 3 squared. So whether it starts in the numerator or starts in the denominator does not matter. You can always just move it to the other side of the line and change its exponent from a negative to a positive. What else you got?
6 over n times negative square in parentheses.
Like this, or just the n?
Like that.
So, again, the minus 2 applies to both. And one of the properties of exponents is I can separate it into this and that.
Mm-hmm.
Okay. Now I can move,
Switch it.
yeah, I can move the 6 to the other side of the fraction line and the n to the other side of the fraction line, producing that, and that is n squared over 36. And that's the answer you'd want to give.
Mm-hmm.
Now, I suppose the other thing you could do here that's actually a little faster is immediately switch it to n over 6 to the positive 2. In other words, I could go immediately from this step to this step if I wanted, and that actually gets me to the answer a little quicker, and it's about the same. There's not a lot of difference. Math is like that. There's usually 2 or 3 ways to do something. What else you got?
Negative t over 3 in parentheses, and then squared.
Can you speak up just a little bit? There's a little bit of static in the background. I don't know if you can...
Negative t over 3 in parentheses, squared.
That's it?
Yeah.
Okay. Again, I can write this as... Well, first of all, let's talk about something. Negative p over 3 is the same as negative p over 3, and that's the same as p over negative 3. All of those things mean the same. So where I put that negative sign doesn't really matter. If I want, I can think about it as negative p over 3 squared, and I know that when you square a negative number, it turns positive. Or I can think of it like this. Negative p squared over 3 squared. In other words, separated into 2 fractions. And then negative p quantity squared is the same as p squared. 3 squared is 9. So there's your answer.
Mm-hmm.
But I actually could have gotten that directly if I'd have looked at it like this and maybe get it a step easier. Well, I can virtually disregard the negative sign because I know it's going to turn positive, so I immediately get p squared over 9. Maybe a little quicker to go that route rather than that route. Not always about speed, about understanding also, but what next?
In parentheses, 3s to the power of 8, and then out of the parentheses, negative 5, power of negative 5.
Okay. First of all, tell me what the answer to this is.
Would it be, I know it would be like something f3 over...
2 to what power?
What? Oh, it would be power of 3.
No,
because,
it's the power of 12. Hold on, I'm talking about down here.
Oh, the answer to that one.
I want to make sure you understand the concept. And the concept is when you're doing double exponentiation, you multiply.
Yeah.
So it's 2 to the power of 12. If I'm doing multiplication and I have 2 to the power of 3 and I am multiplying that by 2 to the power of 4, then you add the exponent. There's multiplication, there's double exponentiation, and there's division. And when you're doing division, you subtract the exponent. But you can only do those things if your base is the same. Okay? So, first of all, first thing I'm going to do is apply the negative 5 to the 3. So that becomes that. And then what about the x to the 8? What happens to that immediately?
Doesn't it get multiplied?
Correct? So do it. What is the answer?
It would be 40, negative.
Negative 40. So if I'm going to write it in the numerator, it's x to the minus 40th. But I'm assuming your class is like every other class and they want the answer with positive exponents. So I've got to move that x to the other side of the fraction bar. And 3 to the 5th is 81 times 3, 43. Okay? In other words, whenever you have this double exponentiation, apply the exponent to each term. Apply it to your number first, apply it to the second variable. If there's another variable in there, apply it to that. In all cases, you're multiplying exponents. What else?
Negative 5p to the power of 3, and then out of parentheses to the power of q.
The power of what?
And then it's cubed.
Cubed?
Yeah.
Okay, tell me what to write.
For one thing, you have negative 5 to the power of 3.
Okay, do I want to put that in parentheses?
No. Yeah, because...
Yeah, you do. In other words, if I'm going to separate it out, I got to separate that whole thing out. And then what else?
And then p to the power of 9.
Correct? What's minus 5 cubed?
Negative 125.
Uh-huh. So there's your answer. Okay? Yep.
Negative w to the power of 3 over 6. In parentheses, and then out of parentheses, negative 2.
Like that? Exactly?
Yeah.
Okay. Again, let's split everything up. And again, that negative 2 applies to the negative sign also. So when I split this thing up into a divisor and a dividend, I've got to write it like this. Okay. Now I can just flip, right? In other words, I'm going to put the 6 to the negative 2 in the numerator, make it a positive 2. And I'm going to put the minus w cubed in the denominator and make it a positive 2. Now, what's the final answer?
36 over negative W squared, main cubed to the power of 2. Or,
Combine those. Doing double exponentiation, what do you do with the exponent?
oh, it becomes a positive.
Becomes negative
Oh,
W
over 6 to the power of 6.
yeah, to the power of 6. Now there's one last thing you can do. I don't need that negative sign because negative W to an even power always turns positive. So the real final answer is 36 over W to the 6th, no parentheses needed. You see why that I can do that?
I actually don't.
Okay, let's take the number minus 2. Square it. Well,
Oh yeah, negative 2 times 1.
means minus 2 times minus 2.
Mm-hmm.
And minus times minus is plus. So that becomes 4. And if this was to the power of 4, it would still turn it plus. If it was the power of 6, it would be plus. If it's an odd power, then it does not lose the minus sign. In other words, if I said minus 2 to the 3rd, then that's minus 2 times minus 2 times minus 2, that's minus 8. So it all comes down to whether it's an even or an odd power. And in our case, it's an even power, so I can lose the minus sign. And this is considered simplified. You might lose a point credit if you gave this answer that's right above it. What else you got, Logan?
1 over 2 r to the power of 6, to the power of
To what to the power of 6?
2r. And that's all those in parentheses to the power of negative 6.
Like that?
Yeah.
Okay.
So it would be 1 to the power of negative 6 over 2 to the negative 6 over 30, no, over with times r to negative 36 power.
Like that. Okay. Now what's 1 to the negative 6?
That would just be 1.
Alright, so let's just leave that as a 1. What can I do with these numbers down below?
You make them go to the top.
Correct. Put them on the other side of the fraction bar. I end up with 2 to the 6th, r to the 36th. Then I have a 1 down below, but I don't need to write it. If my 1 is in the denominator, I don't ever need to write it. If my 1 is the only thing in the numerator, then I do need to write it. In other words, I need to write it when it's in the numerator like that. But when it's in the denominator, I don't. Now, do you know what 2 to the power of 6 is?
That would be
64.
okay.
2, 4, 8, 16, 32, 64. So there's your answer. Oddly enough, I had a session with a geometry student earlier today, and this is a honors geometry student, not your brother, but somebody else with the same teacher, ANSAC. And this was the stuff they were doing, which is actually fairly similar to your stuff. It's only it involves a lot of radical sign. But I'm surprised at how close the two material is. You have to pretty much remember the same rules. Okay, what else you got?
Now we're working with, we have to evaluate the expression and then write the answer in scientific notation and in standard form.
Okay.
So it's in parentheses, 3 times 10 squared.
I just want you to write what that number is.
No, and then we have another, it's in another parentheses, like multiply, 1.5 times 10 to the negative fifth.
You kind of treat these like they're variable. In other words, you can multiply the two numbers, and then you can multiply those two by using the rule of exponents. So what does that give you?
2.25.
No, 3 times 1.5 is 4.5.
Oh.
And then times 10 to the what?
10 to the negative 10.
Negative 3. I'm going to add these two exponents.
Oh, yeah, you're adding.
Okay, so that's negative 3. And that's in scientific notation. Now, if we want to know what number that is, then we move the decimal point this many places to the left. So if I put some 0 markers in there, and I move it 3 places, I move it 1, 2, 3. Right there. So this number is 0.0045. That's what number they're talking about.
Mm-hmm.
So let's take another example just to make sure you understand. What is this number?
3 times 10 squared.
What number?
Oh, yeah, it would just be 300.
Right. And the way I can handle this one is by writing it 3, put some zeros in there as markers. And because that's a positive 2, I'm going to move the decimal point 2 spots to the right. And there's my answer, 300. Now, there's one additional rule about scientific notation. Let me give you this problem right here. What's the answer to that?
The answer to that would be 20 times x to...
Not x. That's a multiplication.
Oh, yeah, times 10 to the 5, fifth power.
Yeah. It's a little bit odd that they would give you scientific notation after starting algebra because once you get started with algebra, you tend not to use x to mean multiplication anymore because it's confusing. And so they'll either use a dot or they'll use parentheses or they'll have a number next to a letter, and that means multiplication also. However, even though that is the correct answer, it is not in correct scientific notation. Correct scientific notation dictates that this number right here has to be between 1 and 10. So I got to turn it into a 2.0. But by doing that, I got to add one more to that number right there. So this is actually the correct answer in scientific notation, 2.0 times 10 to the 6th. You see what I did?
Mm-hmm.
Okay. Now, they may not be giving you anything that complicated yet. So far, all questions I've seen on scientific notation results in a number between 1 and 10 here. So they're not making you do those conversions yet. At least not that I know of. What's next?
Then it's in parentheses 6.1 times 10 to the negative third power.
Times 10 to the negative 3?
Yeah.
Okay.
And then times 8 times 10 to the 9th power.
Okay, here's one, a good example where they are going to do it to you. Times 10 to the 9th?
Mm-hmm.
Okay, so what's the immediate answer? Or what's the next line? Let me put it that way. Always do these one step at a time. 6.1 times 8. Multiply 8 times 6 to get 48.8. See that?
Mm-hmm.
Times what?
Times 10 to the 6th power.
Yeah, except that's not in scientific notation. So what do I have to do?
You have to move the decimal to the left.
And do what to the exponent?
Right, just make it go up one.
Right. So the final answer is 4.88 times 10 to the 7th. So they did give you one where after multiplying you ended up with a number that was not between 1 and 10. So you have to adjust it. And sometimes you'll have to go the other way. In other words, maybe they give us a problem where it's 0.48. Then I got to move the decimal point to the right by 1, which means I got to take it down by 1. So it depends on whether you're dividing by 10 or multiplying by 10 or 20 or whatever it be. All right, we got time for one more, Logan. What else you got?
6.4 times 10 to the power of 7 divided by 1.6 times 10 to the 5th.
Times 10 to the 5th?
Mm-hmm.
Okay, what's 64 divided by 16? Whole number. Small whole number.
4.
And the fact that it's 6.4 divided by 1.6 doesn't change anything. That's still 4. Times 10 to the what? What do you do when you're dividing? What do you do to the exponent?
You subtract 1.
So what's this?
That would be 2.
What number is that if we're not writing it?
Oh.
That's scientific notation. But if they wanted to know what the exact number was, what is it?
Squared. Or 4 times 10. Squared.
Well, the other way to think about this is that's 4 times 100, right? 10 squared is 100. There's always as many zeros as there are the sides of the exponent. And 4 times 100 is 400. So if you're ever in doubt as to how to convert these to real numbers, take a small number like this where you know exactly how to do it for sure. In other words, you know that 10 squared is 100. All right. Logan, I will talk to you next Tuesday at 5.
Okay.
That time still works for you?
Yeah.
Okay. Have a good week. Talk to you next week.
Bye.